So we'll continue with problem number 4, and this is a trig function. Before we start this one, I'm gonna make a note over here about a substitution. So we have note that 1 over secant x is equal to cosine of x. So as I'm rewriting, before I want to evaluate, I can rewrite this as cosine of x times, and then also the tangent of x is equal to the sine of x over the cosine of x. Those are some side notes. So 1 over secant x is cosine of x. And then for the tangent x portion, I'm going to rewrite that as sine of x over cosine of x dx. And then of course you can simplify here before we ever start. That will cancel here, and then so I'm still rewriting this, and this could be simplified as the sine of x dx. And then basically you just go to your integration rules right there. So the integral of the sine of x is just negative cosine of x plus a constant. So we'll just jump back down here, and the antiderivative is negative cosine of x plus a constant. So most of the work done there was just on some simplification and some trig properties. Alright, our next one, 5x cubed plus 2 cosine of x. I'm just going to use one of our formulas up above to rewrite this and pull the integrals out front. So first of all, the integral of a sum is the same thing as the sum of the integrals. So previously we would do this with derivatives. We can take the integral of 5x cubed dx, and we would have the integral of 2 cosine of x dx. So we can break them apart just like we did with derivatives. The other thing we said we can also do, and I think I highlighted it in the first video, is pull these coefficients in front of the integral sign. So 5 integral x to the third dx plus 2 integral cosine of x dx. Alright, and then now this puts this in the format that we've been using, so we're going to work with that one. So that's just going to be 5, and we're ready to evaluate this. So it's n plus 1 over n plus 1. So x to the n plus 1, so 3 plus 1 is 4, divide by 4, okay, and then of course we'll do the plus a constant at the end, and then I have that 2, and the antiderivative of cosine of x is just sine of x. And we'll simplify that, so you're just going to get 5/4 x to the 4th plus 2 sine of x, and then plus a constant. We must always remember at some point at the end to put in plus a constant. Okay, moving on. So we're going to look at this. You can break them apart individually and show that. I'll probably do that for another time or two, but eventually you can just evaluate it just like we did with the derivatives. But let's break it into individual ones. So we'll have 8t cubed dt minus 6. Now I want to rewrite that as an exponent, so that's t to the 1/2 dt plus, and I'm going to bring this one up as a negative exponent dt. So you can kind of do that all at one time. So minus the integral, minus the integral. Okay, let me just make sure I didn't miss anything there. So pulled them each apart separately, rewrote anything with exponents, and used negative exponents so that I don't have a fraction. Okay, my next step is I can pull out the constant. So I have 8 integral of t cubed dt minus 6 integral of t to the 1/2 dt, and that one I'm just going to leave alone, t to the negative 2 dt. Okay, alright, so now we're ready to start evaluating the antiderivative. So t to the n plus 1 divide by n plus 1. Alright, over here t to the n plus 1, which will be plus 1 will give us 3/2, and then that would give me, divide by n plus 1 would give me the 2/3 out front, but I also still have this 6 that's out here, so I'm going to put the 6 out here. Okay, and then my last one, plus t to the negative 2 plus 1 will be 2 to the negative 1 divided by negative 1. Alright, let's see what all we can simplify here. So this will reduce, and we would have t to the 4, 2t to the 4th. Okay, and this next one, that would just give me a 2 here, and then I would have negative 2 times 2, which would be negative 4t to the 3/2 power. And then I'm just going to bring that negative up, and that's going to just be t to the negative 1, which I move it to the bottom so that it's a positive exponent. I'll have 1 over t plus a constant. Okay. For this one, because it doesn't look like it fits the format of any of our integration rules that we have, our common integrals, so we're going to do as much as we can algebraically. So the first thing I'm going to do off to the side is I will FOIL that out and simplify. So x squared minus 1 times x squared minus 1, distribute that out. When you get that and you rewrite it, let me put it in orange, I would have had x to the 4th minus 2x squared plus 1. So FOILing out the numerator, you should get that, and then of course it's over the denominator. So our first step is we're going to FOIL and simplify. The next thing we want to do is we want to simplify this, so right here, and I'll kind of do it as we go. That's just going to give us x squared. If I do this one, that'll just give us reduced to negative 2. And then if I do this one, I'll have 1 over x squared, which is the same thing as x to the negative 2 if you write it with the negative exponent. So you can break them apart individually like we've done in the past, or you can just go ahead and integrate all at one time. So I'll take the antiderivative of x squared, so it's x to the n plus 1 over n plus 1. 2 is just minus 2x. When you have just a constant, you add the variable to it. And the last one is just going to be x to the n plus 1 over n plus 1. So if it simplifies to the negative 1 over x, rewriting that without negative exponents, and then of course we remember plus a constant. So just like before and just like we did derivatives, if you have the opportunity to algebraically simplify things first, probably your better option, so that you can use one of the rules that we were given. So we have a trig function here, and we're going to try to simplify this just like with most trig functions. You try to rewrite it in terms of something that we have and something that we know. I don't have cosine of u, cotangent u if you look back at your rules, but I can consider 1 over the cosine of u and consider 1 over the cotangent of u to see what that might give us if we were to rewrite, and just see if that helps anything. So 1 over the cosine is secant of u, and 1 over the cotangent is tangent of u, and of course du. So I'm going to scroll all the way back up here to see in our trig integral of secant u tangent u, so that's this one. So we just take the antiderivative of it, which is secant of x plus c. So when it matches one of our rules, we'll just come here and evaluate the antiderivative to be secant of u plus a constant.